So last day we were finding the concentration of the ion, of the hydrogen ion, and then solving for whatever we wanted to solve for. Today we are going to be having an unknown acid, some acid that we don't know what it is, but we would like to find its Ka value. So that's what we're doing today, is we're calculating the Ka value of an unknown acid. So we have an unknown diprotic weak acid, okay, an unknown diprotic weak acid is found to have a hydrogen ion concentration of 0.060 molar when we mix a 2.50 molar solution of the acid. And now we're going to calculate Ka. So, first thing you need to do is write the dissociation so you can have a start for your rice table. Do you remember what to do with diprotic acids? How many hydrogens do we take off? Just one, okay? So when we write the dissociation, remember that only the first dissociation of a polyprotic acid is important for Ka calculations. Unlike titrations, where both hydrogens get neutralized, okay? I bring this up because you're going to be dealing with some of those like on Monday, okay, with the titrations. Unlike titrations where both hydrogens get neutralized. But if it is a dissociation, which is what we have for our rice table, it's only the first one. So we just have one H plus coming off. And the other H stays attached to the A. Now we have 2.50 molar of the acid. What row is that 2.50 molar going to go into? That's going to be our initial concentration of the acid. Okay? If you are being asked for Ka, you must be given hydrogen or pH, or you could even be given OH, but that would be weird, but you could be given OH and use Kw to find H. It's a strange kind of a question, though. It will always be given in the question, and that hydrogen ion concentration that you are given is always the equilibrium concentration, because what's the initial concentration of hydrogen? It's always nothing, right? So you can't have, because remember, it's always 0 to start with. So if you are given hydrogen ion, and in this case you are, we're told that hydrogen is 0.60 molar. That's going to be the equilibrium concentration, because the initial concentration is 0. All right, so we can go to our table and we can put in a few things. We have our reaction here. So the initial concentration of H2A is equal to 2.50 molar. And the hydrogen and HA initial is equal to 0 molar. So we can plug in our 2.50. And we are given our equilibrium concentration of H plus, and we know that these two are initially 0. And what that's going to allow us to do is we say, in order to get from 0 molar to 0.6 molar, the change had to be plus 0.06. And that means that HA is also going to be plus 0.06 because these are all 1 to 1. Okay? And that means that our reactant is going to have to go down by 0.06 molar. Now, do you remember how last time we were like, assume X is insignificant? Yes? And we did that so we did not have to solve a quadratic equation. I would like you to look at this 0.060 and tell me, is that 0.060 insignificant compared with 2.50? No, it is not. Okay? So you will not end up with a quadratic equation. Okay? So it's only ever X that you're going to assume is insignificant. The other ones, you can actually do the math and see, is it insignificant? If you do the subtraction and it doesn't make a difference, then it doesn't make a difference. But do the subtraction, maybe it will make a difference. Okay? So, do not assume that a real number is insignificant. So here's a common error. Students, instead of writing the actual numbers, they will write X in the rice table, and then that leads them to assuming X is insignificant. So make sure that if you have a real number to put in the rice table, you put the real number in instead of X, because sometimes that'll lead you to making assumptions that are not true. So now we now we have to write our Ka expression. Remember, Ka equals, and then your square bracket over square bracket. Plug in your numbers from the equilibrium row. Do the math, and guess what? You get an answer, and it goes to 2 sig figs, and you are done. Yes. Why is it not in brackets like this? Because I don't need it to be in brackets? It doesn't help? Right? Because I'm not squaring it, I'm not multiplying it by anything. It can just be on the bottom. You can put it in brackets if you want to, but you don't have to. Does that make sense? Right? So it would be like if I had 0.060 divided by 4. I don't have to put the 4 in brackets. I could, but I don't have to. Now, if you did make an assumption and you said, oh, let's assume that this number here, which is a real number, which we shouldn't make assumptions about, assume it was insignificant, then you would get a wrong value for the Ka. It would be out by a certain amount. Okay? So, that's it. Okay, here we go. We have a question here. An 0.25 molar solution of an unknown weak acid, actually I should say an unknown monoprotic weak acid. You should usually be told, although it doesn't matter, you just take off 1 hydrogen anyway. Has 1.8 times 10 to the negative 8 molar hydroxide. Calculate the concentration of OH minus. Or no, it doesn't say calculate the concentration of OH minus. My brain made that up. It says calculate the Ka of the weak acid. Sometimes my brain doesn't brain very well. What formula could you use for your weak acid? It's unknown. Yeah, what should we call our weak acid? We need to write a formula for it. NOH, it's a weak acid. Acid. HA. HA is good. You could also call it HX. Yes? Sometimes people call it HW for weak. Okay? It really doesn't matter as long as it's just kind of like, here's an acid. I kind of prefer HA or HX because tungsten is actually W, but no one's going to think you're talking about tungsten because it's not. It would never be used in this context. But anyway, doesn't matter what you use. Because we are dealing with an acid and it is weak, what tools are we going to use? Rice and Ka. Now, let's look at our rice table. We have HA, our acid here. It dissociates into H plus and A minus. But sadly, I have not been given H plus or A minus. What have I been given? OH minus. There's no OH minus. What do I do? Oh no, oh no. You're going to calculate it, okay? Because we know that Kw divided by hydroxide gives us the hydrogen ion concentration. Honestly, I don't think I'm going to give you a question like this. You know, it seems convoluted, complicated, but, you know, it's just so that you realize that, yes, an acid does have a hydroxide ion concentration. And so we do our calculation, 1 times 10 to the negative 14, divide by 1.8 times 10 to the negative 8. So this is our concentration of H plus. Is this the initial concentration of H plus or the equilibrium concentration of H plus? That is our equilibrium concentration. Because we find it here and here. And remember, what's our initial for always for the dissociated part? Always 0 and 0. So we know that we are told that our weak acid concentration is 0.025 molar. Is that the initial concentration or the equilibrium concentration? Initial. Concentration of HA, initial. So we plug it in here. And here's a chance where we can say hydrogen went up by 5.56 times 10 to the negative 7. So A minus also goes up by 5.56 times 10 to the minus 7, which means that HA goes down by 5.56 times 10 to the negative 7. And you can look at this and you can say, when I actually do that subtraction, does the 0.556 times 10 to the negative 7 actually make a difference? And if you don't know, you can always plug it into your calculator and see what you get. That's always an option. Or you can be like this. You can be 0.025 and you can say 0.1, 2, 3, 4, 5, 6, 7. Is this number going to make a difference to this number? No. You good with that? So if you want to, you can plug it into your calculator and see that you end up with 0.2025, or like you'll end up with 0.0249999 something, right? But you'll actually do the subtraction, use your brain, use your mental capacity to say, oh, in this case, it is much, 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 much smaller, okay? Oh, I called it HZ, except for it was HA up there. So I don't know why it's a Z down here. I need to fix it. That should be an A. There we go. Fix. And we get whatever the heck it is we get. Why didn't I finish that? 5.56 times 10 to the negative 7 squared divided by 0.025 equals 1.236 times 10 to the negative 11. Let's make sure that was a real 0.025, yeah. 2 sig figs, 1.2 times 10 to the negative 11. So we good with that? All right. One last type. Ha! Watch the video and take your own notes. You can do that, or I can teach it to you. Which would you like to do? You want me to teach it? Okay. So what we're going to do is I'm just going to grab my answer key so I can know what the question was, because the question's not even here. Pardon me? Yours is? Oh, hang on. Let's go to my other page then. There we go. Okay. What? Oh, right. There we go. Oh, not that one. There we go. Okay. How did I not end up with this? Okay, that's all right. It should be in here, so I should be able to follow it. Oh yeah, here we go. Okay. I must have printed out an old version of it or something like that. I think that's what happened. So we have 500 milliliters of oxalic acid. So 500.0 milliliters of oxalic acid, which is H2C2O4, has a pH equal to 1.095. This is page 100, in case you're wondering. How many moles of H2C2O4 were initially added to the sample? Okay. Tell me something about H2C2O4. Tell your partner something about H2C2O4. Ah, good. I see people reaching for data booklets. That is a smart move. Anyone need to borrow a data booklet? I got lots. There we go. What do we know about H2C2O4? It's a weak acid. And if it is weak, what are we going to be using? Rice and Ka. Okay, it doesn't matter what we're doing. Okay, now. All right, let's start by drawing a rice table. How about you guys set up the equation, see if you get that correct. Did you successfully take off one hydrogen ion. Good. Now, is there any information in the question that we can pop into this rice table? The pH, okay? Is there anything we need to do to the pH before we put it in? We need to change it into concentration of hydrogen. So tell your partner what the formula is for changing pH into hydrogen ion concentration. Hydrogen ion is equal to 10 to the negative pH. Good, good, good. Where will that number go? Tell your partner, where does that number go? Remember, when you have a hydrogen ion concentration, it's always the equilibrium, because what's the initial concentration always? 0. So we're going to go, okay, that's 0, that's 0. Okay. So 0.08035. Once we have that, is there anything else we can fill in? Yeah, we can figure out our change. Yes. Put in your pluses and minuses. Yes. Your answer should have 3 sig figs, but I'm keeping an extra digit so that I don't get a rounding error. Yeah, in fact, I'm keeping this entire thing on my calculator. Yeah, I just keep track of the fact that I will need 3 sig figs later on. Okay. Now, over on that side there, do we know either the initial concentration of H2C2O4 or the equilibrium concentration? Do we know either of those two things? We don't know either of them. Does it say anywhere? It doesn't say. There's one concentration given to us in the question, and that is our pH. And it says how many moles were initially added. Yeah? So what we really want to find is we want to find the initial moles. If we want to know the initial moles, we need to know the initial concentration, yes? We know the initial volume. We know the initial volume. Yeah? We want to know the initial moles. That's what we don't know. And if you want to know moles and you have volume, what do you need? You need tell your partner. If you want to know moles and you have volume, what else do you need? You need I'm starting with liters. I want to find moles. What do I need to multiply by? Moles over liters. So I need the concentration. Yes? So this is my unknown right here. This is what I don't know. This is what I'm looking for. So you can call it anything. You can call it X, but people sometimes get messed up with that because we're so used to having X be the change. So sometimes I just like to call it CI for the initial concentration. Okay. So that's our unknown. And so we're going to have CI minus 0.08035. See if you can do the rest of the problem. All right? Try it out. I'll come around and check on you. Yes. pH has 3 sig figs. I've written more because I don't want a rounding error. Which one? This says 0.095. So, what? Yes. 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 Good question. See if you can get full marks on this question. I'm going to come along and tell you if you're not getting full marks. You're getting full marks. Oh, great. What did you solve for it? Solve for this one, eh? Oh. 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 Well, you didn't finish your race table, so you're not getting full credit. Finish your race table. Okay. So, where are we starting with for fighting? Nothing. Okay. Now, we are asked with a 500 milliliter sample of our solid acid, how many moles were in that sample initially? So we want the initial moles. So this is our unknown. Yes, call that CI. Yeah, equilibrium concentration is that minus that. Okay, so now instead of this, we can plug in. Yes. Yeah. It makes it a little more complicated. Yes. Oh. Yeah. Sounds right. What was the other two? Little raindrops are made of grace. What do the crows say? Oh, right. Yes. Yes. Well, starting with the KA expression. Yes. Okay. You? Yes, folks, if you're stuck, remember you've done your rice table. What comes after the rice table? K. A. You get a half a mark for writing your KA expression, and it might tell you where to go next. So give it a try. That looks good. Okay, if you want to try that one, you got that one. Look, that looks good. Yes, very nice. Work, that's good. How? You don't know KA? Don't. Well, let me fix you. Ooh. By the way, if there's not two unknowns, you can go look up the KA value on your table. Ah. Hi. Okay. You're good though. Yeah. Yes. Now I'm gonna give you a little trick that I always miss. Okay. So you can move this up here. So now you have this. This down underneath this one. Oh. Yes. Yes. And that makes your math so much easier. Do you know how many years I spent doing it the other way before I was like, years. I spent years with that. Maybe.
No, it's toxic. So it's not like that.
That looks good. Yeah. Yeah. That was not that. Yeah, exactly. I just want to make sure you're on the test, right? Very nice so far. Yeah, yeah, yeah. No. And you're missing something here. This is not zero. That's your unknown. You can write CI, you can also call it X if you want, whatever. It stands for the concentration initial concentration. Or you can call it X if you prefer. If you finish that question, you can try the next one. But yeah. You're still writing it out. Yes, yeah, yeah. For that, okay. Parts of the reaction. So, we do it for all of them. And so the W we have 8 times the weight. And if you put it over water, the water is okay. So it's always products over reactants, but if the reactant happens to be solid or Yeah. Okay, I would just write over here. I would do down here as the other one. So I have, because she just told me I could do stuff. Okay. I did that too. She told me I could do concentrations. Yeah. So the concentrations you put in are okay. Fine. Oh, the answer key should be 3 sig figs. I'm sorry, my bad. Yeah, it's 3 sig figs. Yeah. All right, you good? You okay? All good? All right. Next. So this is good. This is beautiful. Okay. What's next is you need a data booklet. Okay. So, oh, why am I looking at that? There we go. Because you can't have two like this, right? We have this, and so we need to know our so yeah, so this is going to be equal to 5.9. And then you're going to take this equation and solve for CI. Okay. That makes me want to cry, but okay. Okay. And I'm gonna read this one right side up. Okay, so we got that. That's good. This looks good. This looks good. This looks good. Yeah. I think it's okay. You can check the answer B and see if there's like an algebra mistake or something, but yeah. Okay. It should be true. Because there are safe things. No. Yeah. Well, the answer key for the first example only gives 2 sig figs. It should be 3 sig figs, okay?
So why?
You
So this is a
So this is actually the small of the power. So we don't include the power of 10, sig figs. So this one's a 6. When you're given it, so this is what you're originally given, so what was what your original given? Yeah. For weak acids. Weak acids. Yeah, weak acids. You remember the little swing?
Yeah.
So we can see right there. Hi.
So.
Okay. Yeah. Yeah. Because you're going to do it for H times OH and no value of that's true. In temperature, and I'm not saying anything about temperature here, but then like this one, okay? So if it doesn't say you'll assume it's 25 degrees Celsius, so it's got maybe 14. You know, I didn't. You know, control. Right? But we can help. Yeah. Right. Okay. Yeah, so we brought this up, yes. Okay. Folks, I want to show you a little algebra trick that, honest to God, took me years to figure out. Some of you are probably going to look at it and go, of course that's what you would do. Why would you do it any differently? But literally, I was in my first year teaching before I was like, hang on, there's a better way of doing this. So if I have my KA, yes, for sure. So if I have my KA, why is my pen not working? Silly pen. KA is equal to H plus times HC2O4 minus over H2C2O4. I didn't leave myself much room, did I? Oh, well, that's okay. So I got this thing here, and I know that Ka is equal to 5 what is it? 5 point, nobody's going to give me a hand here. 5.9, thank you. Times 10 to the negative 2, and that's going to equal 0.08035 squared divided by Ci minus 0.08035. Now, I want you to watch this, because what I did for years of my life is I would go like this. I go 5.9 times 10 to the minus 2 times Ci minus 0.08035, and then I would multiply that whole thing out. Yes? And then I'd be like, okay, wow, this is a lot of work. And I'd have 0.08035. But what if, instead of multiplying this thing out, what if I took this and brought it down here? Oh, now I'm saving myself a bunch of work. Now I have Ci minus 0.08035. It'll work the other way. It's just more work. Yes? Equals 0.08035 squared over 5.9 times 10 to the minus 2. And now I just have this calculation, and then I add 0.08035, and now I have Ci. Bam! How much better is that? Is anyone doing that all by themselves already? And you're like, Ms. Spence, what is wrong with you? Yeah, see, there's at least one in every class, right? They're like, why would you not do it that way? Are you crazy? But yeah, I did not figure that out until my first year of teaching. I was like multiplying the whole thing out every single time. Anyway, it will work if you multiply it out. If you forget, it just takes you more time. Okay? What the? Oh. 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 Okay. You guys can try example 2 now. If you're still working on example 1 and you want me to show you anything, call me over. But yeah, start working on example 2. Give that a try. Okay, no problem. No problem. Going until the last day. So, I mean, honestly, like, I don't know how to answer that. You know what I mean? I'll go look at the calendar and see what my mark for you. Okay. I guess that's Do you know what I feel like? I feel like tomorrow, rather than giving you a quiz on pH and POH, I would like you guys to do work on rice, Ka, like mixed problems out of Hebden. Because it's like you'll pick a problem out of there and you'll be like, I don't know whether it's a find the initial concentration or a find the Ka or a find the pH, and you need to be able to do that. And I'm seeing like a lot of like sort of pieces missing from people right now, and I'd really like you to have that before the weekend. Yes? Are we good with that? Okay. Would you like me to give you a practice quiz on pH to take home over the weekend? And maybe a practice quiz on Ka to take home over the weekend? And then on Monday, we can like go over them? Okay, and then our test will be on Thursday. Okay. I think that sounds like a plan. All right. Tuesday. What? Thursday is your test. Look, I'll give you practice. We're only going to do practice because it's scores as the rating. And I can send those home every week. Let's see what we can go for on Monday. See, right? Yes. It's actually 366. Oh, you do, folks. That's why it's 2 sig figs. The answer key should be 2 sig figs because the Ka value you use has 2 sig figs. Oh, I got you on K. Good job, Caitlin. Thank you. Okay, so that example number 1 should have 2 sig figs for Ka. Yeah. Yeah. And then you want to say how many moles. All good. I have to multiply. So that's this. Yes, that's mold. What would you need to apply to mold from your diet? Yes, do you have figures? Oh. I was ready to mold for leaders. Yeah. Yeah. This guy. Yeah. Folks, make sure in example 1 that you actually managed to go that extra step to get to molds. Okay, and I got hands up the floor. I'm going to start here and move my wheels in. Okay. Hi. Yeah. Okay, so here's ammonia, right? Ammonia is yes, okay. The problem is they label it something wrong. It's ammonia. Right? Just like these guys are right? So this is not. It is and so it is yeah. This one's an example of a strong bronchoalveolar. These are bronchoalveolar. These are your strong bronchoalveolar. This one, yeah. If you want it. And if you oh, you have more. Yeah. I don't know. I want it. It's like that's fine. Okay. Okay. Yeah. Yes. Ah, the Arrhenius one. Okay, so all Arrhenius acids are also bronzodides. Now, bronzodide bases are these. There are also Arrhenius bases. Those are metal hydroxides. All metal hydroxides are strong bases. They're not. Okay, Arrhenius bases.
Okay, oh, so it's like LIOE.
Yeah. And they just associate.
So they're all strong.
They're all strong. Yeah. It's good? Okay. Right? It's like magic. Pardon me? So much easier. I think I must have said, like, when did I start teaching? I started teaching when I was 24.
Yeah.
And I started when how old are you in grade 12? Like 18, 17? Okay. 18, 19, 20, 21, 22, 23. I spent 6 years. 6 years doing it the like hard way. They're like, whoa. I think actually, I don't even think I figured it out. I think some student did it, and I was like, right? See, there are students out there who are way smarter than me. I run into them every year, and I'm like, whoa, so cool. The only reason I can teach them is because I know more. I've had more experience, right? But they're smarter than me. Huh? Yes. Uh-huh.
Because I thought it was looking here,
Mm-hmm.
so I thought it was like weak acid.
But it's too weak to be an acid because it doesn't go this way.
So it's not. It does.
It does not act as an acid. Yeah.
It wasn't like a group
It's the conjugate base of the ammonium ion though, so it is a weak base.
Oh.
Yeah, tricky, right?
Yeah, I didn't.
Yeah, that's the reason I put it on the quiz though, because no one, like I say it many times and no one ever believes me. So yeah.
I have a question.
Hi.
Okay, so for this one,
Yeah.
it's 3 sig figs, right? But the Ka doesn't.
Oh yeah, that should be
Because
2
the
sig
other
figs.
one-
That should be
yeah, it
2
should
sig
be
figs.
2
Yeah, 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 yeah.
Yeah, nice. Yeah, so it counts.
Four.
Okay, so lovelies, your homework, page 102, 103. This is just 2 questions, okay? Page 99, numbers 1, 2, and 4. All right, and then page 95, number 11. You're welcome to do more questions, obviously, from any of those pages, but that will give you a good mixture of all of the KA type questions. All right? You're
Change up the quiz.
right?
That makes me so happy.
Well, I think it's just going to be better, like, in terms of your, like, yeah. Well, exactly.
Which I feel like I could
Yeah. Yeah. Yeah, so much better than
It's like shadow, just like that. Like, yeah. And then it's not even chemistry.
right?
I know.
It's
It's like chemistry, but like, I mean,
it's just it's kind of learning the ABCs, right? And you can't do it without it, right?
yeah, yeah.
Like it's just nice.
I think if I just apply myself to the class,
You probably could.
I'm missing a little bit of it, yeah.
Not a lot.
I wish you had this sooner, I would like so much more.
Like you're a good person. I just feel like in grade 12 and you're yeah, so you've got a lot of like
I'm only for 6 hours.
I know.
I'm usually so much more
I know. I feel that way.
I'm glad.
Yeah.
I'm glad I feel this way.
I Anyway, trying to work the wall, so I found something that was relatively which is not right. So, anyway, so I felt even like this huge box, so I spent yesterday like cutting these blocks. But now there's like blocks all over my living room and like the black that song on the bubbles.
Oh, yeah.
I get to yeah. Yeah, that's
Yeah.
And then watch it. But
I don't have sorry. I see you there.
and then at the end, it's like right?
How
Go back to the video
it's
again.
like all
Watch
over
it
the
again.
floor, and then
Oh, shit.
this is funny. Yeah, it's not like I'm like, I thought it was back to 80, but yeah, now it's like, yeah. You know what, my son, he's my third year. And he told me, I called Thursday morning to make sure we get something that's going. You know, like, I got it. Right, he's not being himself. But he's like, you know what, next week I'm studying final, I might have to call me all the time during the day. So you know what, like, I mean, honestly, you know, we don't have time moms or dads, you know, and your friends. Yeah, like, you can call me every hour. Since he just resets an alarm, it's like, you're fired. Folks, do you want to look at these titration reviews to take with you, or do you just want to get it tomorrow? Tomorrow? If you want one tonight, you can get it tonight. But you can also get it tomorrow. Yeah.
I remember like and people and it think I would
Oh,
people how like there's so I did
Yeah.
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 Well, like, it was kind of interesting, that's, it's just like, I'm not right here, you know, right, I was like, I would do some stuff.
You know that no matter what you do, it will. Oh. So I thought I knew how to play by accidentally. I just co-represent, prerequisite. So I ended up 1 year behind in my full studies.
Yeah.
But it ended up being okay because I understood this was now we didn't know that thing. But it's on top of it for 8 years. Because some of it happens in our own but I will so I wasn't like myself the I wouldn't be fine that it was just worse. I want to say, but nobody finds it elsewhere. Yeah, I want to do. Yes, but like. I mean, quite honestly, like, go on family friends. And you want to, right? From an hour, so basically, like, I don't know about work and maybe school, or right? Yeah, so that was what my mom ended up doing when I was with my brother. When it was just like we were looked after, but then she was like, you know, they were there. Taught them for a while. Yeah, like, this was a shock for a generation. I think if you don't have to. Some jobs that will have are jobs that I'm not. It's like not to stop. They are not able to do this. Right? No, that. And that's why now sit down. Like get. I'm like, what is on? Not like my God. Oh, where's your kid? Yeah, and I was like, it's more than I guess.
Size like that with some different structure. Yeah. You know, and it's like how big looking at and you put it like that awkward. Yeah, but you mentioned awkward. You know, like, if I wasn't sad, I would just. I'm so happy. Oh, this chapter, yes.
Also, I think, remember at first,
Yeah. Yeah.
Yeah.